Hello everyone, this is session number 4 in the quantum mechanics numerical session series, and here we'll be discussing more questions from quantum mechanics. And these are advanced level, like means this come in C section of CSR net of 5 marks. This type of questions. In this class, will mainly the questions will be variational principle and oblique method. Okay, so yeah, let's solve these questions. So, I think this question number will be the question number will be 18. Okay, we'll be continuing the question numbers because then at least we'll have some sense of achievement that we have done this many questions. Right. So yeah, estimate the ground state energy of a one-dimensional harmonic oscillator of mass m and frequency omega using a Gaussian trial function. Okay, so this is from whenever there is given as Gaussian trial function, you will understand that this question belongs to what? This question belongs to variational principle, isn't it? So ground state energy of a one-dimensional harmonic oscillator of mass m and angular frequency omega using a Gaussian trial function. So we know Hamiltonian of a harmonic oscillator, one-dimensional harmonic oscillator is how much? Hamiltonian is minus h cut square by 2m minus h cut square by 2m d square by dx square by dx square, right, half plus half m omega square x square. This is the Hamiltonian for one dimensional harmonic oscillator. All right. Yeah. So Gaussian trial wave function. Here we will assume for harmonic oscillator, we will assume the Gaussian trial wave function as suppose phi x. Suppose phi x is equal to a e to the power minus alpha x square. Okay, alpha x square. We assume this one as our Gaussian trial function for what? For harmonic oscillator. Okay. So first of all, see, these things we have to remember, okay? So whenever we are taking for harmonic oscillator, the Gaussian trial function is this, and the normalization constant, if you calculate, if you calculate normalization constant, it will be 2 alpha by pi, 2 alpha by pi to the power 1 by 4. Okay, 2 alpha by pi to the power 1 by 1 by 4. Okay, and the whole this you have to remember. This is a shortcut. Like once you calculate this, you have to remember this so that you don't have to calculate the normalization factor again and again. Okay, so phi x will be what? 2 alpha by pi. Phi x will be 2 alpha by pi. 2 alpha by pi to the power 1 by 4 to the power 1 by 4 e to the power minus alpha x square. Okay, 2 alpha by pi to the power 1 by 4 e to the power minus alpha x square. Right. Now what is the method of calculating these things in variational principle? First we have to find the um, expectation value of what? Hamiltonian. That will be your expectation value of kinetic energy plus expectation value of potential energy. Okay, expectation value of kinetic energy plus expectation value of potential energy. Then we will do what? We will take the derivative of this Hamiltonian, expectation value of Hamiltonian equated to 0, from where we will get the minimum value of Hamiltonian, which is your what? With respect to what? With respect to alpha, this one. Okay, we'll always do with respect to alpha. That will be 0. From there we will get H minimum. Whatever get alpha value we'll get, we'll put it here. We'll get H minimum, and that H minimum is actually your what? Energy in the ground state or whatever. Yeah, H minimum. This is a variational principle. Alright, let's do this. If you solve this question, you will understand what I'm saying. So first thing is expectation value of kinetic energy. Expectation value of kinetic energy. So we can do it like minus h cut square by 2m minus h cut square by 2m integration minus infinity to infinity. First the wave function, write the wave function 2 alpha by 2 alpha by pi to the power 1 by 4, but it will be squared, right? So 2 alpha by pi 1 by 2, now e to the power minus alpha square, e to the minus alpha square d square by dx square, d square by dx square or del square by del x square e to the power minus alpha square alpha x square dx. Right, so this is it. Next what, we'll take this normalization constant out. So this one is minus h cut square by 2m minus h cut square by 2m 2 alpha by pi 2 alpha by pi to the power 1 by 2 to the power 1 by 2 integration minus infinity to infinity, integration minus infinity to infinity e to the power minus alpha x square d square by dx square of e to the minus alpha x square dx. Okay, so first one we'll take one derivative first. So d by dx of this will be what, minus 2 alpha x minus 2 alpha x e to the power minus alpha x square dx. All right, so this is one. Once I took the derivative, now I will take the derivative again. So let's do one thing. Let's write this whole thing as k for now, right? So that we don't have to write it again and again. Minus infinity to infinity e to the power minus alpha x square. Okay, take the derivative again. This minus 2 alpha will go out. Okay, minus 2 alpha and dy dx of x e to the power alpha minus alpha x, so that will be e to the minus alpha x square. From here and try to do yourself, don't just copy paste it. Minus 2 alpha x square e to the power minus alpha x square. Okay, do the derivative yourself, integration, derivative, everything. Now what can I do? I can take the e to the minus alpha x square as common. So this one is becoming, let me do one thing. Okay, anyway, see, I took this minus 2 alpha here outside and write it whole as k. Okay, okay, got it. Now this is your k minus infinity to infinity e to the power minus 2 alpha x square. Okay, minus 2 alpha x square 1 minus 2 alpha x square dx. All right, now next is equal to k integration of minus infinity to infinity. If you check, you will see e to the power minus 2 alpha x square dx, e to the power minus 2 alpha x square dx uh, minus minus infinity to infinity, minus infinity to infinity. What is there? It, two. Wait, I took this outside now. Oh, it's still coming, right? Yeah, no problem. 2 alpha x square e to the power minus 2 alpha x square dx. Okay. So see now, what formula I will use? Minus infinity to infinity e to the power minus ax square is equal to root over of pi by a. Okay, this is the formula. And minus infinity to infinity, okay, x to the power m into e to the power minus alpha x to the power n dx. How can you remember it? First comes mn, so m then n is equal to 1 by n factorial. These formulas you have to remember. 1 by n factorial gamma function of m plus 1 by 2, sorry, m plus 1 by n divided by alpha to the power m plus 1 by n. Okay. So if you apply this formula here, this one will be what? Root over of pi by 2 alpha, pi by root over of pi by 2 alpha. This one will be what? 1 by 2, 1 by 2 gamma, 2 plus 1 by 2, that will be 3 by 2 divided by alpha to the power 3 by 2. Alpha to the power 3 by 2. Alright, 1 by 2 is gamma 3 by 2, alpha to the power 3 by 2. Okay. So gamma 3 by 2 is how much? 1 by 2 gamma 3 by 2, gamma 3 by 2 is 1 by 2 gamma 1 by 2. Okay. 1 by 2 gamma 1 by 2, which is what? Which is root pi by 2. Gamma 1 by 2 is root pi. So root pi by 2. And divided by, this is another 1 by 2 here. 1 by 2. Whole divided by what? Alpha to the power 3 by 2. Here alpha is what actually? 2 alpha. So 2 alpha to the power 3 by 2. Right? Yeah. No. This won't be cancelled. Okay. So we'll just put the values here. Okay. After you put all the values, you will get what? Just a second. After putting all the, just a second. Yeah. So after putting all the values, you will get what? Do that yourself. After putting all the values, you will get it as minus alpha only. Okay, minus alpha. Okay. Now, also potential energy expectation value. This is a kinetic energy. Kinetic energy expectation value is minus alpha. Potential energy expectation value is what? What is it? What is potential energy? Half. Potential energy is half m omega square x square, isn't it? M omega square x square. So this one will be what? Half. I can write it like this or not, tell me. Half m omega square. Expectation value of x square, isn't it? Expectation value of x square. Hmm. So I can write it like this. Expectation value of x square, how will I calculate? Hmm. How will I calculate this? See. Hmm. Expectation value of x square. See, this will be okay. I think. Hmm. Yeah, that's correct. This is correct. Again, you have to take the integration minus infinity to infinity, and this is your 2 alpha by pi to the power 1 by 2 to the power 1 by 2. Okay, square to the power minus 2 alpha x square dx. Same integration. Okay, same integration. You just do same integration. So after, how will you do it? Again, same 1 by 2 Okay, gamma 3 by 2 divided by what, 2 alpha to the power 3 by 2. Okay, so after doing this you will get it as 1 by 4 alpha. Okay, whole integration thing, this will be there half m omega square into 1 by 4 alpha. Okay, so now do what, we have got kinetic energy, we got potential energy. Oh, this one, okay, sorry, this h cut square by 2m was there, right? So this one will be h cut square by alpha, h cut square alpha by 2m, yeah, because minus h cut square by 2m was outside, right? Yeah. So, yeah, so these two, now I can write, mm, I can write h as what, t plus v, expectation value of kinetic energy plus expectation value of potential energy, that will be what, h cut square by alpha, h cut square alpha by 2m plus m omega square by 8 alpha. Now what do we have to do, we have to take the derivative with respect to alpha, isn't it, as we have, as I told before. To add more slides, right. Okay, so let's take the derivative of that one. So d h by d alpha is equal to 0, isn't it, dh by d alpha, that will be equal to 0. So take the derivative. So if we take the derivative, that will be h cut square by 2m. Okay, alpha derivative is 1 minus m omega square by 8 alpha square is equal to 0. Okay, so from this we can calculate, if we take the this to other side, alpha is equal to m omega by h cut. Okay, you can simplify this one, you will get what, alpha is equal to m omega by h cut. Right, now what, just put it in the place of h minimum, that is in place of h, so it will be h minimum, that will be what was the thing, h cut square alpha by 2m plus m omega square by 8 alpha. Okay, so alpha is what, alpha is your m omega by h cut, put it, so h cut square by 2m into m omega by h cut plus m omega by h cut plus m omega square by 8 m omega by h cut. Cancelled, h cut h cut h cut h cut cancelled, h cut, and this one is cancelled, omega cancels, this is omega, so this becomes h cut omega by 2. Okay, h cut omega by 2 plus h cut omega by 8. So I'm making a mistake. Yeah, no problem. This will be what? This will be 4. This is plus 1, 5. H squared omega by 8. Okay. This would be answer for what? H minimum. Wait, there is a mistake. Just a second. Should not got 5 because H minimum in harmonic oscillator is how much? Half H squared omega, right? It's 5 by 8 to H. 5 by 8 H squared omega is a mistake. Okay, this is a mistake here. Okay. This should be alpha on this side. It's 2. So this is a 2 here, right? Okay, let me do it again. So alpha square is equal to, my bad. So I can do it like, I can do it as h cut square by 2m. H cut square by 2m is equal to m omega square by 8 alpha square. Okay, this is 2, this is 8, this is 4. So alpha square is equal to, yeah, I was missing it too. Alpha square is equal to m omega square by 4 h cut square. So that is equal to what? Alpha is equal to what? M. So this is also m square. So alpha is equal to m omega by 2 h cut. Okay, alpha is equal to m omega by 2 h cut. So we just have to put 2 h cut here. There is a 2 here. There is a 2 here, alright. So this is 4, and this one also make 4. So this is your 4, and this one is also 4. So this whole thing becomes what? H cut omega by 2. Alright. That it's very lengthy question. So if you do a simple mistake, everything will be wrong. That is the thing. So this is your half h cut omega. Half h cut omega. Alright, this is the answer. Yeah. Yeah. So this comes for 5 marks, right? So if you're able to do this, you'll get 5 marks. And I did it here, so that's why it was kind of slow. Okay, but if you do yourself, you can solve it quickly. Next question. Next question is like that only. The Schrödinger's equation of a particle is defined as this much. So you have to calculate what? Uh, you use the trial wave function x exponential a minus ax, obtain the base value of parameter a. You just have to calculate a here. All right. So again, phi is how much? This is a big question number. How much? Question number 19. Question number 19. So phi is equal to how much? Phi is equal to x e to the power minus alpha e to the power minus ax. Okay. So x e to the power minus ax. So just um, what if we okay, same process again, same process we have to do. First, the kinetic energy expectation value you have to get. All right. Kinetic energy expectation value is how much? Again, minus h squared square by 2m here. Yeah, minus h squared square by 2m here, and here what? Um, x square. Okay, x square e to the power minus 2ax. No, 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 no. My bad. Okay, minus h squared square by 2m 0 to infinity, minus infinity, minus infinity to infinity, right? Uh, X e to the power minus alpha x into d square by dx square, d square by dx square, x e to the power minus alpha or ax, whatever, dx. Okay. So the double derivative of this one, okay, you will get only what? You will get it as e to the power minus alpha x. So I will write the whole integration thing. This will be your minus h cut square by 2m, right? And this will be your, I can write it as minus alpha, minus infinity to infinity, alright? This whole inside part will become what? A square, I'll write it, a square x square e to the power minus 2 alpha x, okay? Try to do it yourself, this one. And upon solving it, you will get h cut square by 8 ma square, okay? Sorry, 8 ma only, 8 ma. Exactly the same thing you will do for potential energy, right? Potential energy also you have to do. How? Again, same thing. Potential energy is given as mgx. Okay. So goes out. Mg goes out 0 to infinity. 0 to infinity. X cube e to the power minus 2 alpha x dx. Alright. How did x cube come? X is from here. Okay, x square from here and x from here. Okay, how x square? Because it will be like psi star psi, right? So psi star is x only, psi also x square, and then another x from potential energy, so x cube, right? And this integration, if you calculate, see same thing, 1 by n gamma m plus 1 by n, m plus 1 by n whole divided by alpha to the power m plus 1 by n. Okay, this is the formula you have to use here. This is the formula you have to use. So 1 by n, that is 1 by 3, isn't it? 1 by 3. So this is m, na? This is m, this is n. mn. So mg into 1 by 2 gamma 4 plus 3 plus 1 by 2, that is 4 by 2, that is 2. So gamma 2 is actually how much? Gamma 2 is 1 divided by alpha to the power 1. Okay, right? Wait, no. Sorry, I'm sorry. This integration will be done differently. This is for even powers of x. This is not for this one. Okay, this one you have to calculate. You have to solve it the lengthy way, and after solving it, you will get it as how much? 3 mg, 3 mg by 8 a fourth. Okay, this would be your potential energy expectation value. This is the kinetic energy expectation value, and you will just add them. You will get what? H. Okay, h, you will get h will be how much? H will be h cut square by a, h cut square a square by h cut square a square by 2m plus 3 mg by 2a. All right, so yeah, 3 mg by 2a. Yeah, so from there you can take the derivative with respect to a and make it 0, isn't it? Take the derivative with respect to a, make it 0, and after that you will get the value of a. Okay, you get the value of a as, the answer will be 3 by 2 m square g divided by h cut h cut h cut square. Alright, so this would be 1 by 3. Right, that will be your answer. Okay, yeah. So yeah, that will be it for this class. This was a class on variational principle. All right, and I will try to do more questions. I could not do this many questions in this session because I got some urgent work. So you could have seen that I was doing it very fast. So yeah, but I will try to do it elaborately in the next class. All right. Okay. Thank you very much.